right, for this problem, we have a 5th degree polynomial. So there's a lot more work on this one to get it all the way down to linear factors. We're going to need to have 5 linear factors. We will start out by using the fact that since we know 4i is a 0, because that was given to us, remember, we also can conclude that negative 4i is also a 0, which basically tells me that, therefore, we also know that x minus 4i and x plus 4i are factors. So basically, I'm going to come up here and say, I know that this is going to factor as x minus 4i times x plus 4i times some other things. I'm not sure what other things we're going to multiply by, but there will be some other things. So in order to figure out what is left over here, right, what I still need after I've factored out the x minus 4i and x plus 4i, I need to actually divide that out of the original polynomial p of x. But it's ugly with the minus 4i plus 4i, so I'm going to expand that. You can also take your time and do this using FOIL, but this is by a difference of 2 squares pattern going to equal x squared minus 16i squared. And now we get x squared plus 16. So basically what I can do is say, now that I know I have x squared plus 16, even though I don't want that in my final answer, I still do want x squared plus 16 in order to be able to divide that out. And I'm going to do that using polynomial long division. So I have 3x to the 5th minus 4x to the 4th plus 35x to the 3rd minus 70x squared minus 208x minus 96. And I'm going to divide by x squared plus 0x plus 16. And now I'm just going to go through the polynomial long division. So in order to get my first term, I'm going to multiply by 3x cubed, which will be 3x to the 5th, and then plus 0x, and then plus 48x cubed. And now in order to subtract, I'm going to change those signs and add on down. And that ends up being negative 4x to the 4th, and then minus 13x cubed. I'm going to drop down the 70x squared, the negative 70x squared, because I know I'm going to have 3 terms once I do the next step. Now I need a negative 4x squared. And when I multiply that through to everything, I get negative 4x to the 4th plus 0x. Sorry, I should up here have to the 4th, plus 0x to the 3rd power, and then minus 64x squared. And again, I'm going to subtract by changing the signs and adding on down. And that ends up giving me negative 13x cubed minus 6x squared. And now I'm going to drop down the negative 208. And next I need minus 13x. And so let's see, I get minus 13x cubed plus 0x squared. And then 16 times 13 is 208. So that's nice. And at first glance, I was thinking, wait a second, I get cancellation. But now, oh, and negative 208 I should have here. But now I can see my middle term is not going to be 0. So we don't get full cancellation. So now I'm going to change those signs and add on down. And I end up with a negative 6x squared and then plus 0x minus 96. And if I do negative 6 here, I end up with negative 6x squared plus 0x minus 96. So as I complete my polynomial long division, I do get a 0 remainder, which I should because I have been told that 4i is a 0. So therefore, negative 4i is a 0, and therefore I know that x squared plus 16 should divide nicely into this polynomial. So long story short, what I'm left with up here is now this quotient right here is what I'm going to put up there. So this is 3x cubed minus 4. Sorry, I'm too close to the top. Let me shift this down a little bit so it's easier to see. 3x cubed minus 4x squared minus 13x minus 6. Now, the problem isn't done, but what's nice about this problem is it has now turned into a problem just like the other ones that we were doing before. Specifically, the one that was exactly one problem before this in the homework. Because in that problem, remember, we were being asked to write a polynomial in factored form, and it was a cubic. And this is also now a cubic that we're trying to write in factored form. So I'm going to go ahead and throw that into my calculator real quick, see if I can identify a 0. Now, in my calculator, I can actually see several promising looking zeros. And so I'm going to try to find the one that's sort of the nicest looking 0. And let me just make sure I've got that right. 3x cubed minus 4x squared minus 13x minus 6. So it looks to me like I've got a 0 at -1 and another 0 at what looks in the calculator to be at around -2/3. I'm going to choose the nicest 0 that I see, which is x equals -1. Looks like a 0 for my cubic. I'm going to use that to try to figure out how I can factor that cubic. So I'm going to go off to the side here and do synthetic division with the cubic, 3x to the third, and -4x and -13x and -6. So that becomes my synthetic division setup where my root is a -1, and then I have 3, -4, -13, and -6 ready for synthetic division. So now I'm going to do -1 times 3 is -3, -4, and -3 add up to -7. I multiply -1 and -7 and get 7. And then I add -13 and 7 to get -6. And again, multiply -1 and -6 to get 6. So these add up to 0, which tells me that this is going to factor, and I will end up having x plus 1 factored out. That's because -1 was a 0. And I'm being left with 3x squared minus 7x minus 6. Now, if I could factor that nicely, then I would factor that nicely. And it is possible that that's going to factor nicely. As I play around on the calculator, it does look like this is potentially going to work out because I can see that I have another 0 at 3 in the calculator, and I have a 0 at -2/3. If it looks like those weren't there, I wouldn't even try to factor it. I would just go and use the quadratic formula just like in the last problem. But I'm going to play around with factoring this because I think this is going to work out. I have 3x and x here. I need everything in the end once it's FOILed out to have a middle term of -7. So I'm going to try a -3 and a +2, and you can kind of play around with that. And this ends up being 3x squared minus 9x plus 2x minus 6. So that actually works out in this case. So therefore, if I go all the way back up to the top, I now can break that down even a little further. And instead of having the cubic up there, I can write down my final answer, which is going to be the factors that I started with. And then also, see if I can get this guy working. Also, 3x plus 2 and x minus 3. And that would actually be my final answer. And when you write your final answer in the answer blank, remember it does ask you to say, you know, P of X equals. So don't forget to include that as well. Now, if the question had been slightly different, and if it had asked me to list the zeros, then I would have listed 5 values as the zeros. It would have been 4i, -4i, -1, -2/3, and +3. But this problem is just asking me to write this as linear factors, so this is how far I get, and then I'm done.